We're on the second video of our limits and continuity notes here, and we're on page 4 looking at indeterminate forms. So there's 4 different types of indeterminate forms. The first one is 0 over 0. We can't divide by 0, so that makes sense why that's an indeterminate form. We also can't do infinity divide by infinity. Now we would think it's 1, but that's not the case. We don't actually know what happens when we divide infinity over infinity, because these are concepts. Infinity is a concept. Same thing, we don't know what infinity subtract infinity is. It's not 0. We still don't know what happens here. It's a concept minus a concept. And lastly, 0 times infinity is not 0. This is again is an indeterminate form. So if we ever get these forms while trying to evaluate the limit, we need to massage the function first, or in other words, we need to manipulate the function before we can actually take the limit. So we saw this last time. We had an example like this where we had to factor the numerator. You could also factor the denominator to see what you can cancel out. Because if I stuck this 2 in here right now, we're going to have a problem. We're going to get 0 divided by 0, and that's the indeterminate form. So I'm going to factor the numerator, which is x minus 2, x minus 3. These cancel out, so you're just left with x minus 3. Now we can evaluate the limit. That's 2 minus 3, plugging in that 2 in there, and our overall limit is -1. The next one is called the expansion trick. You just expand the numerator or the denominator depending on the case, and then simplify. Before we begin, you can already see we have a problem. If I plug the 0 from my x, we're going to get 0 on the denominator. If you plug in 0 here, you're going to get 0 at the top as well. So we're going to expand this x minus 3 squared. Remember, this means x minus 3 times x minus 3. So this is actually x squared minus 6x plus 9. We have that minus 9 from the original one. And then I'm going to simplify the numerator. And then I can factor out the x in the numerator. The x's are going to cancel out, so I'm just left with x minus 6. Now I can evaluate the limit by plugging that 0 in. So notice how I'm keeping my limit sign at the front always. You have to do that until you hit the end of your simplifying. The next trick is called the common denominator trick. So whenever you see a fraction that's adding or subtracting, make sure that you put the fraction together by finding a common denominator. In this case, our LCM, or LCD, is 3 times x plus 3. So just combining these two different denominators. So I want to make sure that this numerator is 1 fraction instead of 2 right now. So I'm going to multiply this x plus 3 fraction with 3, so I can have that LCD. So I'm going to multiply that to the top and bottom. And then I'm going to multiply this 2 over 3 with x plus 3, top and bottom. And this is still all over x. Now I want to simplify. So we have 6, the numerator, minus, I'm going to expand this, 2x minus 6. And leave our denominator alone. And then instead of writing this over x, I'm just going to move it here and say that this is the same thing as 1 over x. We'll continue. So I'll subtract this 6 minus 6. And then I'm left with negative 2x, my numerator. Now you can see that we can cancel something out. We have an x divided by an x. So we only have negative 2 over 3 times x plus 3. Now we can evaluate the limit, because if we plug this in, we're not going to get 0 over 0. Okay, so now 3 times 3 is 9. Our overall limit is negative 2 over 9. The last trick is the conjugate trick. So every time you have a radical, you can just multiply it by its conjugate in the numerator or in the denominator. It doesn't matter where this radical is. We can always multiply it by the conjugate. So it gets rid of it, and then we could hopefully simplify and evaluate the limit. So if I plug in a 9 right now, that's 0 over 0, and we're going to have a problem again. So the conjugate is just exactly like what you see here, but instead of having a minus 3, we're going to do a plus 3. So I'm going to multiply by the root of x plus 3. This is the conjugate, and I had to do it to the top and bottom. Okay, so then if I multiply this out, root x times root x times positive 3, negative 3 times root x, and negative 3 times 3. I'm going to get the following in my numerator. I'll just be left with x here, plus root 3 minus root 3 is just nothing, so we're just left with negative 9, all over x minus 9 times the root x plus 3. But you can see that we can cancel out this x minus 9 top and bottom. So I'm just left with 1 over the root x plus 3. Now I can evaluate the limit, because if I plug in a 9, I'm not going to get a 0 in my denominator. This is 1 over 3 plus 3, which is 1 over 6, and that is our final limit. Now I want you to pause this video and try the questions on the next page here. It says try these. I want you to try them first, take your time, and then when you're ready, press play again, and I'll explain the solutions. So here are the solutions to your try these questions. In A, we had to factor the top, so that we can cancel out the x minus 4, top and bottom, before we can evaluate. In B, because I have this radical sign, I'm looking for the conjugate. So if I do the conjugate, hopefully we can simplify things and we won't have 0 over 0. So I'll multiply by the root of x squared plus 4 plus 2. So remember the conjugate, you're just doing the opposite sign here. You multiply that by top and bottom, and then you're going to simplify. So when I multiply these two together, I'm just left with x squared plus 4, and then I'll multiply the negative 2 and positive 2, which is just negative 4. Simplify this, you'll just get x squared. You'd cancel out the x squared top and bottom, and then from there you can start evaluating the limit. For C, you want to expand, because you have 2 plus h, and you can expand it 3 times, 2 plus h times 2 plus h times 2 plus h. You're going to get this over here. Then afterwards you want to simplify the numerator, so that'll be 8 minus 8. Then factor out the h, because each term would have that in common. Then you can cancel out your 2 h's, and this is what you're left over. Now you can evaluate the limit, and you should be left with 12. So that's all for this video. It's all about trying to find the limit algebraically using these different methods. You can go into your homework and do those practice questions that I have left in there. And if you have any questions, feel free to email me or to leave something in the communication side here, still empty, in this math chats, and then I'll get to your question.